Hello, it's Keith here, and this is lesson 9 of the simple series of my 650 assembly programming tutorials. This time we're going to be looking at the PC Engine, and we're going to learn how to draw bitmaps on the PC Engine, just some simple graphics using the tilemap. So the PC Engine is of course a console system, and this means that sometimes the setup of the console's hardware, because we've got no firmware operating system doing any work for us, is a little bit tricky, but it's not going to be too bad, and hopefully we'll be able to get through it and learn how to draw some simple graphics onto the screen. So let's go over to our source code and learn how to do it. Okay, so if we go here, and if I just press F6 here, and we select PC Engine here, of course you can download my development tools from my website, which has these scripts all pre-configured, and you can see we've got a little smiley face just here. So we've been able to turn on the hardware and show a little graphic. Now that's not particularly impressive, you know, you're not going to make much of a game with that, but you might be surprised. So we're also going to learn how to combine tiles to show our Chibico character. There it is, just there, and that's what we're going to be doing. So we're going to do those two little examples. Now, as I say, you might think a smiley face isn't very impressive, and of course it isn't, but you can actually build this into something a bit better, because I'm actually, in my Z80 series, I'm now extending this example into a game called YQuest, and hopefully I'll be able to bring that to the 6502 systems as well. Now, if you want to create sprites that you can use with today's example, you can use my Sprite editor. It's free and it's open source. It's written in C#, and it's included in the sources 7 on my website. So please go along. learnasm.net you can go to now, or there's a link to this tutorials lesson document in the description below. So, you know, please check that out. But say you can download this, and if you go to 6502 and you go to PC Engine, save raw bitmap, that will export the file that you need to use in today's example. Okay, so let's go over the code line by line and let's learn how we've actually set things up so that we can show our graphics on the screen. Now the first thing is we're using some 0-page entries for today's example, and you can see I'm defining them just here. I effectively mimic Z80 because I need to think in you know, basically having more registers than the 6502 allows. So I emulate them. So we have a HL for a source, BC for a byte count, and a DE as pairs of 16-bit values here, and we'll see those later on. Now our code is starting at E000 here, which is our start of our ROM. The first thing we're doing is we're disabling interrupts, and we're using CSH, which is a special high-speed mode command on the 6280 CPU. We're then turning off decibel mode, and we're going to have to map in the RAM and the IO pages. And the way that VASM allows this to happen is we use these bit masks here with this TAM command, and what we're doing is we're selecting the hardware bank that we want, and we want F8, which is the RAM, and we're loading that into TAM1 here, and we're doing that with this bit mask here, loading into 2000 to 3FFF range, and then we're loading the IO into the 01FFF range just here with this command. Now you could load them into different ones, but this is going to be sort of pretty typical for what you would expect, and that's what these tutorials are relying on. Next, we're going to just disable some of the IRQs here, just to get things in a simple way that we can work. Okay, so our hardware is set up for us to function, but we now need to make sure the screen is ready to work with our graphics. Now, here's the layout of the hardware. You can see that ST0 is a shortcut command to write to memory address 0 question mark 00, where question mark is any value. Now, a lot of systems you would see use quadruple 0 here or something like that, but with VASM that would actually write to the 0 page, so that's going to be a problem. The 0 page actually isn't at 0 on the 6280 for some reason, but as I say, we will be using 0100, 0102 and 0103 as the hardware register ports. These are the equivalent the same as ST0, ST1 and ST2, but the ST0, ST1 and ST2 can only work with a fixed value, whereas these memory addresses we can write the values up from registers and things like that. Now the first one, ST0 or 0100, will select a register. 0102 or ST1 will write the low value, and 0103 will write the high value, or ST2 that is. So that's how we're doing things. And as I say, you're going to see these quite a lot in the code because we need to do various things. And first of all, what we're doing is we are turning on the background here by writing bit 1 here to register 5. And then we are setting the tilemap size 32 by 32, a small tilemap, not really enough for a sort of scrolling game, but enough for a simple example like this. We're then setting the background scroll. We're using these values here. 00 and 248 here, and these will set the X and Y scroll so that the first byte of the tile map is the first visible tile on the screen. We're then initializing some colors here. We use the 0-4 range here, and we are selecting a palette entry. We're first selecting palette entry 0 here, and you can see we're using 3 bits per channel here. We're then setting color 1, and we're setting this to a kind of purple here, and then we're setting color 2, we're setting it to cyan, and we're setting color 3 to white here. So we've set up a basic palette, and then what we're doing here is we're clearing the screen. Now we're selecting the start of the tile map, memory address quadruple 0, and we're writing that to register 0, which is the address select. And then what we're doing is we're loading XY with effectively 400, and we're looping around. We're repeatedly writing tile number 256, which is our blank tile, to the screen, to the visible screen, that is. Now, why are we using tile 256? Well, tile 0 would effectively be VRAM address 0, and VRAM address 0 is actually our tile map itself. So that's why we're starting from 256 here. Okay, so we've now got a screen that is actually set up, cleared and ready to use. What we're going to do next is we're going to transfer our bitmap to the screen. Now, we could have created this with Sprite Editor, but for clarity, I've not done that. I've actually created it manually as a combination of bits. Now, an image in the PC Engine works in bit planes, and there's 4 bit planes for a 16 color. Now, what you need to think of is if you think of a value from 0 to 15, that will take 4 bits to describe. Now, rather than storing each pixel separately, what they do is they split all the bit 0s, all the bit 1s, all the bit 2s, and all the bit 3s into 4 separate bit planes and store those separately. So effectively here, you can see here's all the bit 0 for a smiley face. Now the body of the face is in color 1, which is why you can see this circular, it's this circling 1s. And then the mouth is in color 2, all the bit 1s are 1 here. Now the eyes are actually color 3, and if you can think of the value 3, you would have bit 0 as 1 and bit 1 as 1, and you can see that represented just here. You can see there's 1s there and there's 1s there. Now we've only got a 4-color graphic, so bit planes 2 and 3 are all blank. The format, as I say, is a bit crazy. You can see bit planes 0 and 1 are sent for all 8 lines, and then bit planes 2 and 3, and that's what we've done here. And we've got this define tiles function that's doing that for us. Now when we called this, we are loading the address of the bitmap in HL, the length of the bitmap in BC, and the destination, which is tile number 384 in this example, in DE. And we're calculating that because effectively there's 32 bytes per tile. 256 plus 128 is 384. We were using tile 128 on other systems, you see, that's why that mathematics is there. And our define tiles function is doing that for us. The define tiles function uses a command called prepare VRAM. You can see it just here. And what this is doing is it's selecting register 0, and that's the address select register, and then it's writing the address we want to write to the other 2 ports. And we can't use the ST1 and ST2 here because we want to use the value in the accumulator this time, so we're using those to select that register. Okay, so we're now ready to write data to video RAM. We need to select register 2, which is the VRAM write port, and then we are just streaming all of the values from HL into those 2 ports in pairs here. And we are then repeating until we've actually finished writing all of the data here. And that will actually, it's a little bit complicated, but that will actually transfer the tile data for a small tile like this, or a combination of tiles, which we've got in this version. If you see here, we're actually loading in from a file, and that's our Chibico character bitmap that you saw before. So we can actually work with any size with this code. We're just using it here for a single 8x8 single tile pattern, but we could use it for something bigger. So once this is executed, we have now effectively defined the pattern data within video RAM, and the last thing we need to do is actually get the character onto the screen, the smiley character in this case. So we're using get VDP screen pos, and we're selecting a memory address 3,3, and so that's a tile map position, and here we are effectively multiplying the Y position by 32, because remember our tile map was 32 wide, and then we're adding the X position. And of course, if your tile map was 64 wide, you would need to increase this. You need to add an extra ASL to just convert it, but in this case, yes, I say this will work just fine. And that's a mistake there, that should say high byte. Now, because the tile map is 32 wide, we will actually need to use the 16-bit combination of the addresses to select the correct position. So we've split off some of the bits here. Effectively, we've just lost them because of all these arithmetic shifts. And then we're taking the remaining bits for the high byte, and we're storing that with the command just here. But the long and the short of it is that this will select the correct VRAM address for an XY position within a 32 by 32 tile map just fine. And that's what we've done just here. We then select our write register with this command here, and then the next values we store to either ST1 and ST2 or to 01, 02 and 01, 03 will actually be stored to the address that we selected here. And what we've done is we've selected tile 384, which is setting the high byte to 1 and the low byte to 128 here, because of course 384 is 256 plus 128, and that shows the smiley to the screen, as you saw just here. So that's how we can do that. Now, of course, if we change our values here, we can reposition the smiley. If I change the X position, you can see it's a little bit further across, and that gives us a lot of flexibility. And this was basically the foundation for the Grime 6502 series I did before. Now, of course, we can extend this further. This time we've loaded in a large bitmap, and our Chibico character is 48 by 48, which is 6 tiles wide and 6 tiles tall. And so what we're going to need to do is Sprite Editor split this up into individual 8x8 tiles, and we're going to need to rebuild it in the same linear format. It goes from left to right, top to bottom. And that's exactly what we're going to do. Define tiles is exactly the same as it was before, but we now have this new fill area with tiles command, and this is effectively at the start of each line calculating the VRAM address for that line, and then it is using the D value, which is the starting tile number, and it's effectively increasing this every time it writes a tile to the screen, looping when it gets to the end of the line, and recalculating the next line so that it does each line across, moving down, and the tile number increments each time. And this is allowing us to draw a larger bitmap image out of tiles onto the screen. And this is a good way of creating a simple, nice looking image just like that. Now, of course, you might want to work with sprites in a game. If this was a real game and your Chibico character was jumping up and down and things, you'd want to use sprites. I've covered that in another series. But if you're a beginner just getting started, you want to keep things as simple as possible. And I'd suggest that your first game should be limited to just tiles, really, at least until you get confident with it. So there we go. So we've had a quick look at how you can get a simple bitmap onto the screen using the tile map. I'd suggest you go ahead and download today's example. But you can get it, you can get all the development tools as well, and then you can have a tweak and a play with it yourself. And of course you can make your own sprites with Sprite Editor. Anyway, I hope you found this little introduction interesting. If you have, please like and subscribe, because that helps with the Google Analytics and everything. They rank you based on how many people like your videos and things. Anyway, if you like this, I hope you'll stick around and check out the other PC Engine content I've made, and I've got lots more planned. Anyway, whatever you do though, I hope you enjoy programming, and I hope you enjoy the PC Engine. Thanks for watching today, and goodbye.